Okay, this is video 1 for the Conservation of Momentum unit notes. The learning goals for this unit, I want you to be able to solve problems involving conservation of momentum. I want you to be able to explain situations using the impulse momentum theorem, and I want you to be able to identify different types of collisions. So, to get started, we need to talk about conservation and what exactly that means. Basically, when something is conserved, then no matter how complicated the situation may be, we can set the value before and let it equal to that value after. So if we have a total amount of, let's say, we're going to talk about momentum. So if we have a total amount of momentum before an event, that will equal the total amount of momentum after the event. And what becomes tricky is when we talk about vectors. When we talk about vectors, we have to make sure both the magnitude and the direction are conserved so that all of the magnitude before is equal to all the magnitude after, and that the direction before equals the direction after. And that can get a little tricky. So let's begin by talking about what exactly momentum is. And starting off with a hypothetical child, let's say we have a child, or a hypothetical question here. Let's say we have a child and a car both traveling at the same velocity. Would you rather be hit by the child or the car? Obviously, you would rather be hit by the child. And we could say the child would have less hitting power in the car. And really, you could talk about materials, child versus steel, but mainly it's going to come down to mass. The child has a lower mass. So what momentum is something that depends upon both mass and velocity. And this is exactly what momentum is. Momentum is mass times velocity. And since velocity is a vector, that means momentum must be a vector as well. So it's a very simple formula. It's just simply mass times velocity. Now, the units for momentum, well, we got mass, that's kilograms, and velocity is meters per second. So the units will be the kilogram meter per second, or you can write it as a kilogram meter per second if you wanted to. A lot of people ask, why P? Why do we use P for momentum? I'm not entirely sure, but thinking about it, I doubt if we would want to write an equation that says M equals M times V. I'm sure that one of the reasons why they chose to use a P for momentum is just so that we wouldn't get confused with using M for mass and trying to use M for momentum in the same equation. So I imagine that's probably why. All right, so during any kind of interaction between two objects, momentum then can be transferred from one object to the next. As an example, think of a bowling ball hitting a pin. The ball is going to give some of its momentum to the pin, causing the pin to move. So what that means then is that the bowling ball pin is going to gain some velocity, which means that the bowling ball then must lose some velocity. And that's simply because momentum being mass times velocity. Well, we can't really change any mass. We can't change the mass of the bowling ball or the pin, but we can change the velocity. Now, what's kind of cool is that the changes in momentum of those two objects will be equal. So the momentum that the bowling ball pin gains will equal the momentum that the bowling ball loses. Again, this is kind of a cool topic if you think about it. So let's take a look at another example here. Let's say we have two girls facing each other and they're wearing skates. So there's very little friction between the girls and the floor. They have their hands touching and then they push on each other's hands. We want to talk about what is the momentum before, and what is the momentum after the push? Well, before the push, they are both stationary. Their velocities are zero. So before, their momentum is zero. Now, being what it is, what is their momentum after the push? Well, believe it or not, the momentum after the push is zero as well. And you may be wondering, how can that be? Well, velocity is a vector, and momentum is a vector. So that means that velocity can be negative if an object's rolling in the negative direction. So what we have is we have one girl rolling in a positive direction and the other girl rolling in a negative direction, so that those two momentums can cancel each other out. Now, which girl will gain the most velocity from this interaction? Well, it's going to be the girl with the least amount of mass. All right, now, remember that momentum is a vector quantity, so changes in momentum must be found by subtracting the momentum vectors, not by subtracting the magnitudes of the momenti. So that's something that we need to be careful of, and we'll talk about that in greater detail later. That is it for video 1.